Hi everybody, today we're going to go over our TeamTeach Chapter 10 over length, area, and volume. We're going to be discussing about specific figures and shapes and how to solve those in relations to the topic. My name is Amanda Pennington.
My name is Joseph Douglas.
And my name is Jerry Boling.
And so we're going to go ahead and get started and jump in. All right. So Joseph, this container can hold up to 16 gallons, but how many bottles can it hold? And can it hold in quarts, pints, or cups?
Okay, so this is a friend of mine named Mr. Gallon, and he shows us how many of each measurement that goes into one of these. So there are 2 cups in a pint, there are 2 pints in a quart, and there are 4 quarts in a gallon. There are also 2 quarts in a bottle. But so the key with this, since we have 16 gallons, is to multiply 16 by however many of those measurements go into a gallon. So, for example, there's 2 bottles in a gallon, so 16 times 2, that's 32. So there's 32 bottles that it can hold.
Okay. I understand it. Thank you so much for sharing that. That is a wonderful pictorial description of it. Thank you.
Yeah. Jerry, would you like to find the perimeter of this triangle for us?
All right, that's a very simple question to answer. Use the equation side plus side plus side. So you take the first side, which is 48 meters, plus 69 meters, plus 82.3 meters, and you get 199.3 meters for your perimeter.
Okay.
Did I explain that well?
Yes, you did.
All right, Amanda, how would you find the area of a triangle and perimeter?
Okay, so to start with that, we're going to have this figure pop up. This is going to be our triangle. And here we have some measurements going on. So to find the area of a triangle, we know we're going to use the equation 1/2 base times height. So we know that the base is going to be 37 inches and the height is going to be 88.8 inches. So we're going to plug that into our equation. And when we solve it, we get the area is going to be 1,642.8 inches. And then when we do our parameter, just like you taught us, Jerry, we're going to take all the length of the sides and add them together. So that's going to be side A, side B, and side C. So we're going to add that together. And when we do this, it's going to give us our answer of 222 inches as the perimeter. And that's going to be the total amount. So this is how you would find the area of a triangle and the perimeter.
That looks great.
Thank you.
All
right, Jerry, how would you find the area of this triangle?
You do the simple equation of 1/2 base times height. All except for the base is at the top of the of your picture, which is the 88.8 inches, and the height is over there on the side, which is the 37 inches, and that should come out to 1,642.8 inches square.
Thank you. You did wonderful.
Amanda, when you do use height value instead of the side value of this triangle?
Okay, so that's a good question. So we see right now that this triangle is kind of a different shape. So we see right now that there is 2 numbers right here. We know that this is going to be the length of this side, and we know that this number right here, the 2.6 centimeters, is going to tell us the height. Now, for the area of a triangle, you do use the height in there. So when you solve, you'd want to use the 2.6 centimeters in that equation. But when you do the parameter, you want the area of the triangle around it, like if you wanted to put a picket fence around it. So you're going to use that 3.1 centimeters to get your answer. And so that's why you would use the height value in the area when solving for a triangle instead of the parameter.
Thank you. That was great.
Thank you.
Okay.
Joseph, can you tell me how to find the area and parameter of this triangle?
Yes. So the first thing we need to do is find the length of the missing side here. The Pythagorean theorem states that a squared plus b squared equals c squared. So in this case, 5 squared plus, we'll call this b squared, equals 16 squared. So what we have to do is take 16 squared, 256, minus 25, which is 5 squared, to get 231. The square root of 231 is about 15.2. So that's, we'll say b equals 15.2. So then for the area, we take 1/2 base height. So 1/2 times 5 times 15.2, which equals, it comes up when you click it, I think. Let's see, there we go, 38 inches squared. And then for the perimeter, it's 5 plus 15.2 plus 16, which equals 36.2.
Thank you so much. You did a wonderful job explaining that.
Thank you.
You're welcome.
Jerry, how do you solve for the perimeter of this triangle?
You take each side and add it together, not the height volume, but each side, which is 6.2 centimeters plus 3.1 centimeters plus 8.5 centimeters to get your grand total of 17.8 centimeters for your perimeter.
Great job.
Joseph, which is longer, the area of the small perpendicular circle, or the area between the boundaries of each circle?
Okay, so we need to find the first thing we need to do is find the area of this circle right here, which the values, can we click it? The values were on here. Oh wait, no, there it is, sorry. It has a length of 16 units. So the length of this square of one of these sides is 16 units. That's the same as the diameter. And half of that, the radius, is 8. So we use 8 as the radius in the pi times radius squared equation to get an area of the yellow circle for about 201.056. Then to find the area of this entire thing here, we need to find the diameter of this big circle, which is the same as the hypotenuse of half this. So 16 squared plus 16 squared is about 512. So 22.627 is about the diameter of this big circle, which divided by 2 is 11.314 squared times 3.1415. So that we get a total of about 402.133 for this entire circle. We then subtract this from this to get the area between there, which is 201.077, which means the area between these, the picture's not drawn to scale, the area between these two circles is just barely larger than the smaller circle value.
Okay. Sounds great. Thank you.
Mm-hmm.
All right, Jerry, how do you find the area and the radius of this figure?
Oh, you start out with the radius. The radius is half of the units, of the length of the units, which that is 10 units. And then how you find the area is use the equation A equals pi radius square. So you take pi times 10 square equals 100 pi units. And then the larger circle equals A square plus B square equals C square. And you take 10 units square plus 10 units square equals 200. And times pi.
All right, Great, thank you. You did wonderful explaining that. I now understand that the diameter is always going to be double the radius, and the radius is going to be always half of the diameter. Thank you.
So, Amanda, how would you solve for the ratio of each volume object for here?
Well, that's a good question. So we see right here that we have this cylinder, and inside this cylinder, we're going to have a triangle or a pyramid or cone, and we're going to put also a sphere in this cylinder. So all of these shapes are in this cylinder, and we need to find out the ratio to where they are. And so to do that, we're going to look at the volume of a cone, the volume of a sphere, and the volume of a cylinder. Well, what we do is we're going to divide all of these by the volume of a cone. And so we see that the volume of a cone is 2/3 pi r cubed. And so we're going to divide it by that self. And so we know that anything divided by itself in math is always going to be 1. So that means that the volume of the cone is going to be a ratio of 1. The volume of a sphere is going to be 4/3 pi r squared, and we're going to divide that by the volume of the cone, the 2/3 pi r cubed. And that's going to give us the result of a 2. And so the ratio of the volume of the sphere is a 2. So the volume of a cylinder is going to be 2 pi r cubed, and we're going to divide that by the volume of the cone. And that's going to give us a 3. So the ratio is going to be 1 to 2 to 3 for the cone, sphere, and cylinder.
That was great, Amanda.
Thank you.
All right, Joseph, find the area of each shape. Explain how these areas relate to one another.
Okay. Okay, so here we have a cone. Both the cone and the sphere are clearly inside the cylinder. It's honestly not completely easy to tell whether the cone is partially inside the sphere, or I'm honestly not sure about that. I guess it is. But so to find the comparison, we first need to find the area of each of these. So for the cylinder, so the height of the cylinder and cone, which measure the same in this case, is 25 centimeters. And the base of the cone, or the radius of the base of the cone and the end of the sphere and cylinder is 14 centimeters. So to find the volume of the cylinder, we take pi times the radius squared, which is the radius is 14 in this case, times the height, which is 25, which means the area of the cylinder is about 15,393.35.
Wow.
Yeah, it's big. So for the cone, we'd have 1/3 for the this should be a V for volume, not an A. We have 1/3 times pi times radius squared times height, which would be the same as 1/3 of this shape here, 15,393, which we get 5,131.12. Now the sphere should be, I guess, about halfway between these two, so my math might have been off on this one, because I thought it was 4 times pi times radius squared. So 14 squared. I was wrong in this case. It should have been about 10,000 something, I think. But the methodology is still the same. It's pi times radius squared times either 4 or 4/3. And then we compare all these down here as a ratio, and then which will, if divided, would add up to about, it's ready to click, 1 to 2 to 3.
Great job.
Thanks.
Jerry, how would you find the surface area of this figure?
We'll use the simple equation of surface area equals 2 times base plus perimeter times height. And how you get the base is use 1/2 A plus B. Your A is 26 centimeters. Your height, your A is 26 centimeters. your B is 17 centimeters. And your height is 12 centimeters. So you take 1/2, 26 plus 17 times 12 equals 258 centimeters square. Then you gotta get your perimeter. You add each side together, and you get 70 centimeters. And then you plug everything into the equation, which is surface area equals 2 times the base, which is 258, plus 70 times 4, which equals 796 centimeters square.
Thank you so much. You did an awesome job.
Okay, Amanda, how would you solve the surface area of this right trapezoidal prism?
That's a good question. The thing that helped me the most when looking at this figure was that I decided that I'm going to cut it into a rectangle and then cut it into a triangle. So break it down into 2 shapes. And so on the next side, this is like an area looking down on this shape, broken down. You can solve the area of the rectangle, and we know that its area equals width times length. So we plug in the 12 times 17, gives us 204 centimeter square unit. And then we're going to look at the area of the triangle. And so we'll plug in 1/2 times 9 times 12, and then that gives us the area of 54 square centimeters. And then when we go on, we're going to minus the 26 from 17. And this is due to when this whole side is together, it adds up to 26. So we just need to find this length of the side. So we're going to minus the 17, and that gives us the 9 centimeters. And so when you see that we're going to add the area of the rectangle and the area of the triangle together, and that's going to give us the base. And that gives us 258 centimeter square unit, which is the base. Now we'll find the perimeter. The perimeter is adding up all the sides, which is 70 centimeters. The 4 centimeters is the height of the shape. So we're doing 70 times 4 equals 280 centimeters square unit. And we're going to add this right here, the 280 centimeter square, plus 2 bases because you have a top one and you got a bottom one for a 3D figure. And when we add it all together, that gives us 796 centimeters square unit for the surface area. Jerry, find the surface area of this figure.
You start out with finding the area, find the area of the top of the figure, which is 1/2 base times height. So you start out with the area equals 1/2, 15 meters times 7 for the height, which equals 52.5 meters. And then you do the perimeter, which is side plus side plus side, which is equal out to 40 meters. Then you plug everything into the surface area equation, which is 2 times 52.5 meters plus 40 meters times 7 meters, which equals 385 meters square.
Great job, thank you. All right, Joseph, what is the name and surface area of this shape?
So we know this is a type of prism because it's not a cube, but it's a 3D shape made up of like different rectangles and stuff. And specifically, there's a right triangle here for the base of the shape, which means this is a right triangular prism. So to find the surface area of this, we first need to take the base times the height, 17 times 8, which equals 136. And then another side over here will be 7 times 8, which is 56, and then finally 5 times 8, which is 40. Those will all be added together. To find the area of the right triangle, we take area equals 1/2 base height. So 1/2 times 17 times 5, which gives us 42.5. And since there's 2 of them, we multiply 42.5 times 2 equals 85. Add 85 to these 3 over here, 56, 136, and 40. We get the surface area is 317 centimeters squared.
Thank you so much. You know, I actually did not know what shape that was, so thank you so much for informing me on that.
Sure.
Amanda, why would you use the formulas for a sphere and a cylinder to solve for the surface and volume of this shape?
Okay, so that's a good question. And a lot of people, they look at a shape and they think that they're just going to use one equation for a shape. Well, in this figure, you can clearly see that in the middle there's a cylinder, and on the ends there's half of a sphere. But we know that 2 halves make a whole. So because this figure has 2 different shapes on it, we are going to have to use the surface area and the volume equation set for these and add them together, because this figure is adding both figures together. So to make sure it's right, we have to have both equations together as well. And that's why you need both of them.
Thank you. That was great.
You're welcome.
So, Amanda, why is it important to know what the height of the cone is?
That's a good question. When you first look at this figure, you know that you get a height. But again, like I said previously, you have 2 different figures, so you're going to need those. We know with the surface area, we're going to have the 2 different equations for the surface area of both figures, for the cone and for the cylinder. And with this, we already have one height right here. And we can see that it's the 10 for the cylinder because that's the cylinder equation. So we can solve that for the surface area. But we need to know H2. And the reason why is because the volume requires us to have the height of the second one, of this cone right here, to know what it is. So we have to know what that is to be able to solve for our volume. And that's why we need to have both heights in the instance to know how to plug them into the equation to get the right answer.
All right, Joseph, what is the volume of this shape?
That's an excellent question. Can we click on this?
Yes.
There it is. So it's the cone plus the cylinder together. So because it's made up of a cone and a cylinder, we need to individually find the volume of the cylinder and the cone. So for the cylinder, it's going to be pi times radius squared for the circle times the height. So in this case, pi times 3 squared times 9, which gives us 254.46. For the cone, the volume is going to be 1/3 times pi times radius squared times height. So we can just take the 254.40. Wait, actually, no, there's a different height, sorry. 1/3 times pi times 3 squared, same radius, times 5, because that's the height of the cone, and that's 84.82. So I think it's ready to click again. We add both of those together, and the total area equals 339.28 meters squared.
Thank you so much for breaking those apart for us.
Mm-hmm.
So that is the end of our show. We thank you so much for joining us. If we can do anything else for you, please comment below or just contact us. Also, we hope that we share something that can help you when you're doing your math equations. And again, I am Amanda Pennington.
I'm Joseph Douglas.
And I'm Joey Boling, saying goodbye. Have a good day.